Mankind has been exploiting natural resources from the Earth's crust throughout its entire history. There are over 30,000 abandoned mines situated only in Europe. Most of them have been closed and flooded for tens or even hundreds of years. The reason for their closure was mainly because it wasn't feasible to continue mining the ore reserves at the time. Today, the situation has changed. With ever-growing demand for raw materials, the ore prices have been steadily increasing. We also gain knowledge and develop technologies that allow us today to mine lower-grade ores or deeper ore bodies. With today's know-how, we can re-enter these old mines and effectively extract lower-grade material that was in the past considered as waste.
There are a lot of abandoned mines in Europe. Most of them has been closed down because of different economic reasons and not because they run out of ore. This means that this mine still contains a lot of useful minerals. When the mining is stopped, the tunnels are usually flooded and a lot of information about geological structures and ore reserves has been lost.
Exploration of old mines and the collection of data from old flooded tunnels is impossible without costly dewatering. However, such data, together with surface observations, would help geologists to plan much more cost-effective drilling programs. In this way, the mining companies would save a lot of money. So, how can we collect data from the flooded mines? The solution is UNEXMIN, development of an autonomous robot capable of mapping and collecting scientific data from deep, otherwise inaccessible environments of flooded shafts, mine tunnels and caverns. The UNEXMIN project shows a new and revolutionary way to explore flooded underground mines.
UNEXMIN is almost a 4-year-long European Horizon 2020 project which aims to develop an autonomous robotic system which is able to deliver maps and valuable geological information from very harsh environments like flooded underground abandoned mines. The team consists of different fields of experts like robotics, IT, geology, mine engineers and software developers, which represent a lot of institutions from Europe, including Hungary, Finland, Slovenia, Spain, Portugal and England.
UNEXMIN is an EU-funded project that develops a novel robotic system, primarily for the autonomous exploration and mapping of Europe's flooded mines. The Robotic Explorer platform, consisting of 3 robots, will use non-invasive methods for autonomous 3D mine mapping for gathering valuable geological, mineralogical and spatial information. This can possibly open new exploration scenarios so that strategic decisions on the reopening of Europe's abandoned mines could be supported by real and accurate data that cannot be obtained by any other method, without major costs. Once it is put together, the multi-robot platform will represent a new technology line that is only made possible by recent developments in autonomy research that allows the development of a completely new class of mine explorer service robots, capable of operating without remote control. Such robots do not exist nowadays, and UX1 is the first of its kind. So far, the robot has been tested at 2 different mine sites. The first trial was in an abandoned pegmatite mine in Katja in Finland.
Target is on the left wall.
And the second test site was in a historic mercury mine in Idrija in Slovenia. The mercury mine in Idrija, similar to Almedi, one of the largest mercury mines in the world, a mine with over 500-year mine tradition, from 2012 also listed as part of the UNESCO World Heritage Site, today abandoned and partially flooded with water.
Idrija was selected as a trial site to test the UNEXMIN robot prototype because of its very harsh underground environment. The waters here are very murky, the space is combined, and the electricity and ventilation are limited. And this places a very good conditions to test the robot's functionality in harsh and very realistic mine conditions.
Okay, robot in water. To construct a robot which is going to be able to work in such difficult environments needs the cooperation of experts from different research groups. Confined spaces, obstacles, and inability to communicate with the machine presents the biggest challenges. That is why we are constructing a fully autonomous robot capable of independently exploring all workings, mapping tunnels and caves, and making on its own decisions on where to go. With this project, we are pushing the boundaries in robotics and underwater exploration. So far, the results are very promising.
Alpha Omega down.
22. Let's see the bottom.
In September, the project team tested the robot in Idrija Mercury mine, not with the intention to search for new ore bodies, but purely to test its operation in underground conditions and to get a better understanding about the old mine's layout. During the test dives, UX1 robot mapped the entire flooded part of the shaft Borba and collected data for a three-dimensional model of the mine workings, which will be used for presentation and preservation of information from this unique world-class cultural heritage site.
So our future plan is to establish a joint venture company which is offering the service in a more cost-effective and innovative way for underwater investigations on the market, for mining companies and other investors who would like to have the service, but also for special tailor-made solutions what the consumer wants, like able to collect samples.
Let nature set the limits to ore bodies, not the equipment exploring them. The UNEXMIN project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement 690008. This video reflects only the views of the authors, and the European Commission is not responsible for any use that may be made of the information it contains.